Subject AC emissions. Single phase transformers. Subtopics: problems on equivalent resistance and reactance. So here in this last class we have discussed about the transformation of resistance, reactance and impedances from one side of a transformer to the other side and the development phasor diagrams for various loads. Now go for object 2. Here on completion of this period you would be able to understand the solve problems on finding equivalent resistance or reactance or impedances of a transformer and secondary voltage at any load. So here the example problem, we are going for the example problem. A 10 kVA, 500 by 100 volts single phase transformer has the equivalent resistance and reactance referred to primary, that is R01 is 0.3 ohms and the X01 is 5.2 ohms. Calculate the voltage on secondary terminals of the transformer when the load current on the secondary side is 100 amps at 0.8 power factor lagging. So what they given here, a 10 kVA transformer rating is given and 500 by 100 volts single phase transformer and R01 is 0.3 ohms, X01 is 5.2 ohms. What they are asking, calculate voltage on secondary terminals. So when the secondary side is 100 amps at a power factor lagging, here R01 is 0.3 ohms and X01 is 5.2 ohms. I2 is 100 amps, cos pi 2 is 0.8 power factor. Here rating on 10 kVA and voltage is 500 by 100 volts on single phase. Here the pi is cos inverse of 0.8, that is 36.86. So here the transformation ratio is K. The transformation ratio K equal to E2 by E1, that is equal to E2 is 100 volts and A1 is 500, so 100 by 500, that is equal to 0.2. So here K is transformation ratio, K is 0.2. The total resistance referred to secondary is R02 is equal to, here they can return, so here this is the K square, K square into R01, here R02 is equal to K square into R01, so K is 0.2, K square is 0.2 whole square, that means 0.012, 0.2 whole square means that is So 4 into 10 to the power of 4 minus 4, that means 10 to the power of minus 2, not 4. So here the final value is R naught 2 is 0.012 ohms. 0.12 ohms. Here the total reactance referred to secondary is, that is x naught 2. Here also they write k square into x naught 1. X naught 2 is equal to k square into x naught 1, that is 0.2 whole square into 5.2. So here that is equal to, so 0.208 ohms. 0.208 ohms. So from this, from R01 we can calculate the R02. From the X01 we calculated X02. So by applying this, k square is multiplied with the R01 and k square is multiplied with the X01, we get the value of 0.012 ohms, and here also 0.208 ohms. Here total impedance, the total impedance is referred to secondary side. Impedance is nothing but a R plus jx. Here the total impedance, that means here the primary impedance also is transferred to the, referred to the secondary side, and also here the z02 is nothing but R02 plus jx02. Here R02 plus jx02, that is nothing but 0.012 plus j 0.208. So here from this rectangular to polar we get, so 0.208 angle of 86.6 degrees. 86.6 degrees. The secondary terminal voltage V2 is that equal to A2 minus I2 into Z02. V2 is equal to, so it's a secondary terminal voltage, that means load voltage. V2 is equal to E2 minus I2 into Z02. So that is, so here E2 is 100 angle of 0 degrees. Here 100 is the reference, so we can take 100 angle of 0 degrees is the reference. Minus I2 is 100 into angle of minus 36.86 into 0.208 angle of 86.6 degrees. So this is the, so value, so this we can calculate. So 100 plus j0 minus 20.8 angle of 49.83, so that is equal to 100 plus j0 minus 13.44 minus j 15.89. So now this 86.58 minus j 15.89, that is equal to 88 angle of minus 10.39 degrees. 88 angle of minus 10.39 degrees the voltage. This is the voltage across the terminal voltage, that means the load voltage. So here what we have done here, once I can see here from we can convert R1, primary to secondary, we are converted from primary to secondary side. So this, here R0 is given, this point is, this is referred to the secondary side, and also x01 is given, we can refer the x02. From this R02 and x02 we can calculate the z02. From that z02 is, this is the z02 R0 plus jx0, this is the z02 value. Then we are calculating the secondary terminal voltage, the formula is V2 and E2 minus I2Z02. So we know the value of I2 and Z02 and E2. By applying these values, we can calculate the value of V2. This is the V2 value. This is the V2 value. Now go for example 2, second problem. So here a 10 kVA transformer, 50 Hz single phase transformer with trans ratio 10:1 has the following resistance and leakage reactance. That means R1 is given 4.8 and X1 is 11.2 and R2 also given 0.048 ohms and X2 also 0.112 ohms. So here the load current, that is 1 amps, leading the flux by 25 degrees. Load current, that means it is the secondary current. So the secondary delivers 40 amps at a terminal of voltage. Here no load current, not a load current. This is no load current. I0 is given 1 amps. So leading the flux by 25 degrees. And next the secondary delivers 40 amps. This is the load current. 40 amps at a terminal voltage of 250 volts and power factor is 0.8 cos by 2, and determine the primary applied voltage, the primary power factor, the help of vector diagram, phasor diagrams. See here, given data, turns ratio 10:1, R1 is 4.8 ohms, X1 is 11.2 ohms and R2 is 0.048 ohms and X2 is 0.112 ohms and I0 is 1 amp and Pi0 is 25 degrees, I2 is 40 amps. Cos, here this is pi 2 here. This is the pi 2. This is cos pi 2. So cos pi 2 is power factor is 0.8 lagging. So here pi 2 is cos inverse of 0.8, that is 36.86 degrees. Here V2 is 250 volts, that is K is, so N2 by N1, that means 1 by 10, K is 0.1. Assuming V2 as a reference vector. Why V2 as a reference vector? So only V2 voltage is given. So it is the reference vector. V2 is equal to 250 angle of 0 degrees. I2 is 40 angle of minus 36.86 amps. Here Z1 is given 4.8 plus J 11.2 and Z2 is 12.18 angle of 66.8 degrees. So in terms of polar is, so Z2 R2 plus JX2 is 0.048 plus J 0.112 ohms, 0.1218 angle of 66.8 degrees. Here E2 is equal V2 plus I2 Z2 250 angle of 0 degrees plus 40 angle of minus 36.86 into 0.1218 angle of 66.8 degrees. 250 plus J0 plus 4.22 plus J 2.43. So 250 4.22 plus J 2.43, that is equal to 254.23 angle of 0.54 degrees volts. This is the voltage across the secondary induced EMF. Now go for the solution. Here E1 is equal to E2 by K. That means here 254.23 divided by, so that means K here 0.1. So that is equal to, so 254 to 0.3 angle of 0.54 degrees. So I2 dash is equal to minus, I2 dash is equal to minus, so I2K, that is equal to minus 40 angle of minus 36.86 degrees into zero point 0.1, so into 0.1, which gives the, so 4, I2 dash is 4 angle of 143.14. See here in this vector diagram, this is the flux and the I0, I2 dash, this I2 dash comes from the, so I2, so I2 is nothing but, I2 dash is nothing but minus I2 into K. So this combination, so here these two combination will give the I1. So this V1, not V1, V2, I2 R2 and I2 X2 will give the E2, and then E1, I1 R1, I1 X1, which gives the V1. So this is the vector diagram problem. So now from the vector diagram, I0 leads V2 by angle of how much? 0.5 plus 90 plus 20, that is the, so 115.5 degrees. So here I0 is 1 angle of 115.5 degrees, that is equal to minus 0.43 plus j 0.9. So I1 is I2 dash plus I0, that is equal to 4 angle of 143.14 plus 1 angle of 114.5. So by this conclusion, so we can get this value into rectangular, that is minus 3.63 plus j 3.33. From this we can get the value 4.9 angle of 137.7 degrees. So here the primary applied voltage, that is V1 is equal to minus E1 plus I1 Z1, that is 2542.3 angle of 180.54 plus within bracket 4.9 137.7 into 12.18 angle of 66.8, that is equal to minus 254 2.18 minus j 23.96 plus 59.68 angle of 204.5 degrees. And this equal to minus 2596.48 minus j 48.71, that is equal to 2596.9 angle of 181.07 degrees volts. This is the V1 voltage. So here the phase angle between V1 and I1 is, so V1 and I1 is 181.07 minus 137.7, that is equal to 43.37. So here the primary power factor is nothing but the angle between the cosine angle between the V1 and I1, which gives the primary power factor cos pi 1. So here pi 1 is 43.37, so primary power factor is cos pi 1 cos of 43.47 degrees, that is equal to 0.727 lakh. So here this is the summary. So now in this session we have discussed about the way of solving various parameters of transformer, that is equivalent impedances, currents and terminal voltage at any given load, Here now go for quiz. The value of resistance in LV winding, when it's referred to HV winding, so it may be maybe increases LV to HV, so it is increases. Now the equivalent resistance of the primary of a transformer having K is equal to 5 and R1 is equal to 0.1 ohm. When referred to secondary, it becomes how much ohms? So K square into R1, R1 dash is equal to K square into R1. So 5 square into 0.1, that is 2.5 ohms. 2.5 ohms is the answer. Here the frequently asked questions, these are the questions they given, note down it and do the problems. So here a 500 kVA 33,000 by 230 volt single phase transformer has the following data: R1, R2, X1, X2 as given. Find the total impedance referred to primary and secondary and also copper losses determined. And also the next problem here, a 50 kVA 44,400 by 220 volts single phase transformer has resistance and leakage reactances are given R1, R2, X1, X2. So here calculate the equivalent resistance referred to primary and secondary, and it is also referred to impedance and resistance reactance is also referred to primary and secondary, and also determine the total copper losses first using individual resistance and secondary using equivalent resistance. So these are the problems and solve. So thank you.